Okay, I'm Lester Knutsen with Advanced Data Tools and your host for this webcast. And this is kind of exciting. This is the second one we've done this year with over 120 people. And what we want to do is go over the Fastest Informix DBA contest and tell you a little bit about what some of your peers have done to speed up their Informix databases. And I'm very pleased to have Andrew Ford, the winner of the contest, with us here today. And he'll be talking for a little bit about what he did. But first of all, let me just, a couple of footnotes. When you join, if you could put your phone on mute, that would be appreciated. I can do it one at a time here, but it's kind of tedious to do that. And as we get going, I'm probably going to forget to do that. So please put your phone on mute when you join. At the end, we'll have a Q&A, and you should have a button up at the top of the screen. Right now, it should be a green button that says Viewing Lester Knutsen's Desktop. And there is a chat option there where you can ask questions if you click on chat. And I will see the questions and pass them to Andrew if you have them. And, we'll see how everything goes. So first of all, let me start off by saying I really want to congratulate everybody who's participated in our Fastest Informix DBA contest over the years. This is a lot of fun. I call it a very high-pressure event. They have 1 hour to figure out how to make everything go really, really fast. And in real life, you and I, we have the luxury of more time. But let's start off with a little bit of an overview of the benchmark and the contest. And then I'm going to do a demonstration of the contest. And then I'll turn it over to Andrew to talk about what he did that was so unique because he was way faster than everybody else. And then I have two things I'm going to do at the end is I have all the on-config files from the other winners, and we'll go over them. And then we'll also talk about some of the database changes. And what I hope you will do out of this webcast is pick up some hints and tips and tricks on how to make your Informix database run faster. So this year at the Informix User Conference in April, we held the latest Fastest Informix DBA contest. This is the 5th one we have held. And the goal this time was to simulate 1,000 OLTP users running a benchmark on an Apple Mac Mini server. We used an open source benchmark SQL program to generate the transactions. And this is something you can go download and try and use it on other databases to compare your results with what other databases do. And the challenge is, can you take an Informix server running 1,000 users and optimize it in less than 1 hour? Actually, in about 40 minutes is all the time you have. So this time we ran the contest on Apple Mac Mini servers, and they're phenomenal little machines. There's a picture on the screen there of what they look like. They are small, but they are very powerful. They have one Intel CPU with 4 cores, 8 gigs of memory, and 2 disk drives. And a key point that we tried to stress is we ran the benchmark transaction manager on this machine as well as a database. And so the benchmark transaction manager, typically in a benchmark, you'd run that on a separate machine. But here, since we ran it on the same machine, you had to save about 2.5 to 3 gigs of memory for the transaction manager. In an ideal world, it would have been nice to run that on a separate machine, but we said, heck, let's make that part of the contest. And in real life, you have a lot of stuff running on your machine. You don't always have just the database. And we had, after doing this 5 years in a row, we've sort of tightened up the rules a little bit. And what the participants could do is tune and optimize the onconfig file. There were a few things in the database they could change, and then they had to save 10 minutes at the end to run the benchmark. And what we took were the average number of transactions over that 10 minutes. And that was the one with the highest number of transactions in 10 minutes won the contest. And Andrew Ford, congratulations, is the grand prize winner of the contest. And we're going to hear more from Andrew about what he did in just a few minutes. But I also want to highlight some of the others. I like to have a lot of winners, so I try and come up with categories every year for other people to participate. Jeff had the second fastest number of transactions, and he did a phenomenal job on this. Hugo from Austin, Texas, had the third highest number of transactions, and it's always fun. Hugo's in my advanced performance tuning class a year ago, and it's always fun to see someone come out of that class and do really well on this contest. Neil Truby from England was the fastest international DBA. Warren we had to come up with a category for everybody, so we gave him the fastest middle-age DBA. And this is actually a good picture. You can see the Mac Mini that we used for the contest right there in the background on the screen. And John was the fastest senior DBA in the contest and did a phenomenal job on this too. So congratulations to all the winners. It was a lot of fun, a lot of hard work on their part. I sort of liken it to a geek video game where you have 1 hour to solve this problem and make it run really, really, really fast. And everybody did a phenomenal job in doing that. So let me do a quick demo here of what the benchmark actually looks like. And I'm going to connect to my screen sharing. I've got it running on 2 machines. Let's go to this machine first. This is, oops, that other machine in the back is wanting my attention. So I'm going to hide it for a minute. This is a baseline configuration. Every time somebody started the contest, we did non-tape restore, and that took about 10 minutes. And while it was doing a restore, they had 10 minutes then to review the documentation we had there and take a look at it. And once the restore was done and it was online, what I recommended they do is run the transaction manager with the default set of transactions. And this is benchmark SQL. What we would do is enter in 1,000 terminals, 100 warehouses, and run it for 10 minutes. Now, 1,000 terminals equals about 1,000 users, and you'll see that in just a minute. So, first thing we need to do is create the terminals, and this actually goes out and starts creating SQL connections. And so if we go back and take a look, and let's see, right now we have 784, 738. Now we have 1,019 connections, and we should be done. Yes, it says 1,000 terminals connected. Then we hit start, you notice here this number moving like crazy in the middle of the screen? That's the average number of transactions per minute, and that's the score. That's what we kept. And it starts off pretty good, pretty fast, and then usually in the first 10 minutes, it will hit a slowdown, just like your normal everyday computer systems do. They always seem to run great, and then at some point in time hit a slowdown. And so the job of all the participants was how to get this number bigger and how to avoid having it come to a screeching halt. If I was to let this run for about 5 minutes, it would end up coming to a halt in just a little bit. Well, let me show you the other session. This has actually been running it now for the last hour, and this is a more tuned session. It's got 48,000 plus transactions per minute that it's running. And you may see a lag there because going over the internet, the screen is actually slowing it down. That's what we did for the contest. And so each participant had, from the time we did a restore, had about 40 minutes to actually go through and tune the onconfig file and see what they could do to make everything work and run a whole lot faster. And this one's still running pretty good. It hasn't hit the first checkpoint. I'll tell you the secret now is usually after about 5 minutes it hits the first checkpoint and comes to a screeching halt because it has all that memory to write out to disk. Just to give you an idea, if I do an onstat minus P, you can see my write cache is really bad. It's got a lot there in memory that's waiting to be written out to disk. So Andrew, I'm going to turn this over to him in just a minute to tell us what he did. He basically was 3 times faster than anybody else. And he generated over 57,000 transactions per minute. And as you can see, he looked relaxed and calm, playing with his Etch-a-Sketch there, dreaming about the new iPod before it came. So I am going to unmute Andrew. Give me just a minute here, Andrew. Okay, Andrew, can you hear me?
Yeah, can you hear me?
Yes, I can hear you loud and clear. So tell us what you did. This is what everybody's trying to find out.
Well, first I want to thank you for having this contest at the conference. It's always a lot of fun, and I'm even happier that I didn't take home the middle-aged DBA prize this year.
You should tell everybody that's what you did one of the previous years, didn't you?
Yeah. So I guess like after going back and analyzing what I did in that hectic 40 minutes that you have, it turns out that I had like a 3-pronged attack. And the first prong of the attack, I kind of knew what I wanted to do going in, and I had an idea of some on-config changes that I wanted to make and some environment variables I wanted to set, and some disk changes and some schema changes that I wanted to make just as a baseline to get things started. In the on-config, I increased the physical buff and the logical log buffer size just to try to minimize any I/O and keep things in memory as long as possible. I disabled the table space stats because we don't really need them for a benchmark. It's probably a minor improvement, not too much. I added more SOC TCP listeners through the net type parameter to handle the 1,000 connections or 1,000 concurrent users that we were going to have. Increased the VP class CPUs, added 4 CPU VPs instead of the 1 to take advantage of all the cores on the system. Added more AIO VPs. I increased that to 5 and I set direct I/O to 1 since we're using cooked chunks. Didn't want to go too high on the AIO VPs because I knew we only had the one disk, and you can really start to hammer a disk if you get too much going on concurrently. Increase the buffers and the shimvert size to a 50-50 split between the amount of memory that I wanted to give the engine. I knew I was going to tune this later, but just as a starting point, I wanted to give more buffers and more virtual memory to the engine so we wouldn't be dynamically allocating virtual segments during the run. I set my LRU min and max dirty pretty high to try to avoid any LRU flushing during the benchmark run, trying again to keep things in memory as long as possible and hopefully getting through the benchmark without writing out any dirty pages to disk, because I/O, as you can see, is just going to kill any database engine. You touched on this earlier, the checkpoint, as soon as the checkpoint fires, the benchmark slows to a crawl, so I made sure to increase the checkpoint interval to 1 hour in an attempt to avoid triggering any checkpoints during the benchmark run. Since it's a benchmark, it's not a real production system, you don't really have to care too much about recoverability time, so kind of taking the chance that the engine isn't going to crash and we're going to need to recover and avoid any checkpoints. I set use last committed all, and this was debated later if this actually helped or hurt. I still don't know the answer. I turned off the BT scanners just to avoid any index scanning and cleaning during the benchmark run, just to free up those resources as much as possible. Turned on DS non-PDQ query mem, gave a megabyte of in-memory sort space to every non-PDQ enabled session just to avoid any disk sorts and try to do as much in memory as possible. And then for my last on-config change was just setting opcomp index to 0 to prevent nested loops over the hash joins for an OLTP environment. For environment variables, the only thing that I really changed was I enabled opt-OFC. That's optimize the open fetch close of a cursor. And if you do that, you can reduce the number of network messages between a client and server dramatically. And so I think that helped me a lot too. As far as like disk changes or changes to the chunks and DB spaces, the only thing I really did was add 3 large logical logs and move the current log position into that first large log to kind of avoid multiple logical logs filling up within a short period of time and bogging down the engine. And then the schema changes that I made is just change the lock mode of every table from the default of page level locking to row level locking for better concurrency. And so after I had all that stuff set, I bounced the engine, and then, which was new this year, you could actually run the benchmark in your allotted time and take a look at the engine and see what's really going on. And I think that was really helpful. So I did that. I bounced the engine, kicked off the benchmark with 1,000 users, and I noticed 2 things. The first thing I noticed was I only needed about 800 megabytes of virtual memory to support the 1,000 users. So that told me that I could allocate everything else to buffers. And I also saw that I didn't need any more than 20,000 locks, so I could save some space there by not increasing locks to 1 million or anything like that. So just trying to give as much in-memory space to the buffers as possible. And then the other thing I noticed was that the engine was just doing a ton of I/O. It was just hammering the disk constantly. Anytime you'd look at the active threads, it was an AIO VP just spinning away, and everything was just writing. So I just took a look at the scan through onset.SCN to kind of look and see what might be causing all of this I/O, and I saw just a ton of index scans being done. And But this time I was running out of time and only had a few minutes to make one more change. So I took a gamble and just on a hunch, and I don't know if this is what pushed me over the edge or not, but I disabled the batch read index and batch read key only scan to go back to the traditional way of how the engine used to handle it. And I severely reduced the read ahead parameters from the default of 128 pages down to 16, just in an attempt to keep large read aheads from flushing pages out of the buffer that we were going to need. And then the last thing that I did was that I bounced the engine, made these configuration changes, and then for my last 10 minutes, I just let the benchmark run to try to prime the cache, the buffer cache, with as much good information, good data pages as we could before I actually ran the actual benchmark. And that's pretty much what I did.
I was going to say, you did an awesome job, Andrew, and you know, it was kind of interesting watching everybody do it. Everybody did a really good job, but I think you hit some of the key things. If you had to do this again, what else would you like to try?
Well, I don't know.
Next year, what are you going to do? What are you going to do to top this? Now that you've told everybody how to do this.
Well, there are some undocumented opto-FC parameters that I think I would like to give a shot. In the environment, at the time I only thought that parameter was either on or off, but talking to Scott Lashley from IBM, apparently there's all kinds of other parameters, 2, 3, 4, 5, 6, and 7 that are undocumented that I'd like to give a try.
Well, you did a phenomenal job here, and in just a couple of minutes, I'm going to show everybody all the differences between everybody's on configs, and I'd like you to stay on and make a few more comments because I'll have some questions for you then.
Okay.
I want to point out to everybody, Andrew has a really great blog. If you get a chance, it's called the Informix DBA.com, and he talks about all kinds of good stuff about Informix. This latest Informix Remax was kind of fun, Andrew. I don't know where you found that from, but that was great.
It was just very random.
But he's got some good stuff here, and you even have an advertiser from an Informix user. I don't know if everybody knows this, but Southmood Under actually runs the shop on Informix. So this is a good place, good tips out here. Now, what I'd like to do is sort of dive into the on-config a little bit, and I doubt if you can see this. So I'm going to bring it up in the Excel spreadsheet and see if this shows up any better. I think that's a little bit better. Andrew, can you see that okay?
Yeah, I can see good.
Okay. So
now I know what I'm going to do next year.
This is comparing everybody's on config, and all I did was highlighted the changes. The blue is the baseline, the default that we had set up going into the context. The yellow is somebody changed something, and the green is my interpretation of what I think were very good changes. And the first thing, Andrew, you did was you turned off auto checkpoints. And why did you do that? I'm curious.
Well, I was just trying to avoid any checkpoint if possible.
Yeah, and this is the auto stuff is great in Informix. One of the things, though, I've found is in doing performance tuning, the auto stuff works really good when you have a steady state. But I was performance tuning at a bank a while back, and you know, they had a nice steady flow of stuff until Friday payday, and then their ATM network went crazy because everybody was trying to cash their paycheck and get money out. And so if you just monitored and tuned and did the auto stuff, it would work great Monday to Friday lunchtime. And then Friday lunchtime, the auto stuff can't kick in fast enough to hit that peak. I've seen the same thing with other places that have peaks. So if your Informix database has peaks like that, you may want to tune for those peaks. And I think that's a good call there, Andrew. You got the buffers size just about right, and it's interesting. You went with LRU max and men dirty real high. I do the same thing a lot, setting them real low so that they write out continually. And I haven't decided on this benchmark which one works best. They both seem to work good. The key one that you did was setting the checkpoint interval. And then a more important one, I think, was setting the page locking to row. Now, changing it in the onConfig really didn't affect the existing tables. And Andrew did one thing I don't think anybody else did, and he went and changed the existing, and this was one thing that we did allow people to do, the existing tables from page level locking to row level locking. What happens in this benchmark is if you have page level locking, you get a lot of lock errors. And that's fine. It just means every time you have a lock error, you get one less transaction that happens. And so by changing it to row level locking and actually going out and doing the alter table, which takes a fraction of a second to do, Andrew, I think, had a heads up on everyone else with that. Couple of other things, locks. Didn't make the locks any bigger. Other people did, and I think that helps. This is one place where I think you might have overlooked, Andrew. You had the log buffer really big, and I want to come back to what you did with log files because I think that was brilliant. In the onConfig, it doesn't show the fact that you'd reduced it down to 3 log files during the benchmark. You also set the net type for network connections, and we have 1,000 users connecting in over the network. And 4 SOC TCPs with 250 connections each is exactly 1,000 users, and you hit that right on the head, which helps. And this kind of benchmark, setting opt-comp indicator to 0, I think helps too, because 2 is a default, and it means it uses update stats to tell whether it should do scans or what kind of index reads it should use. Setting it to 0 forces it to always use a nested loop join. So what sort of gave you the clue that to set it to 0, Andrew? Whoops, did we lose Andrew? Andrew, are you there? Well, we may have lost him. That's okay. Andrew also set the physical buffer up way bigger than everybody else, which was good. In a benchmark where you are concerned about performance and don't need to worry about recoverability, that works really good. Now, in real life, you probably don't want to do that. Set resident to 2 because he planned on only having 2 segments of memory, a resident segment and a virtual segment, and this forced them both to be resident memory, which is good. Everybody did that in some way. -1, which others did, I think is the easiest because that says make everything resident. Now, shared memory virtual size. Andrew, actually, I think you missed it by a little bit because at the end of your run, when I went back and looked, you actually had 3 or 4 additional virtual segments added. And in my playing around with this, it's really about 1 gig for virtual is probably about the right size to have no virtual segments. But they didn't seem to hurt you in the long run there. Another thing Andrew did that was, I think, really good was focused on, we had 1 disk, and if you have too many processes writing to that disk, they get in each other's way. And by setting the number of AIO VPs to 5, that's about the most that can write to 1 disk at one time. And I think that was a really good setting. Setting the number of CPUs to 4 is on this machine pretty good. You can actually run this machine higher when you don't have the transaction manager running on it, but because it's a very fast CPU. But when you have the transaction manager running on the same machine, you need some CPU power for the transaction manager. So setting the number of CPU VPs to 4 was about right. And the last thing that I think Andrew did that was really good was setting the VP memory cache. This sets up a private cache for each one of the 4 CPUs that it can use for memory first. And you seem to pick the right number there. I was curious. Andrew, are you back on?
Yeah, I'm back. Can you hear me?
Yeah, I can hear you now. So how did you pick this particular number, 8,192 for the VP memory cache?
I mean, it was just a guess. I mean, I knew I wanted to increase it, but, I didn't really, know what I wanted to increase it to. If it didn't help, I didn't want to take away memory from the buffers, which I knew would help. So I kind of just grabbed a medium-sized number out of thin air.
I think it helped. And I don't have a good number to use there either. And I think your guess is as good as mine on what would work. This is one of those things I wish I had time to take each one of these parameters and just run it and nothing else to see what happened and time each one. That would be a lot of fun to do, but don't quite have the time for that.
Yeah, it's hard to know which parameter, which change helped the most because, in your 40 minutes, you have to change a lot of stuff at once. It's breaking the #1 rule of performance tuning. Change one thing and see what it does. See if it helps or hurts.
But you did a phenomenal job there. Let me, before I jump back to the PowerPoint slides, I want to go back to my other screens and just see. So this is the default run, and I just wanted to point it out. It's finished. It finished in its 10 minutes. And out of the box, if you made no changes, you should have got about 6,000 transactions a minute. And that's pretty much was the standard on config, which is actually very, very good when you think about the kind of machine. I mean, this is basically a $1,000 server to be able to get that kind of throughput out of the box with no real tuning. Now, with tuning, Andrew got 50,000. So that's almost 10 times faster than the default configuration. So what we would do after the contest was over, that number there on the screen is what we would write down as and that's what we use to determine the winner. Now, the other thing that I wanted to talk about was outside of the onconfig file, what folks did that really helped. And Andrew did all of these except for update stats. The first thing that he did, which I think made a pretty big difference, is altering the tables to row level locking from page level locking. It's a very quick SQL to do that. I've written several articles on how to actually go out and look at your database and see which tables are row page level locking and how to generate SQL to change that. But that allows you to have less errors. Let me go back to this default configuration. I want to show you something. That's not the default one. If I come over here, it's just finished to run, I've got a whole screen full after screen full of errors. And if you look at these errors, they're all lock errors. And every time you have a lock error, you basically lose a transaction. It doesn't hurt anything, but you lose a transaction. And by changing it to row-level locking like that, Andrew avoided losing transactions, which I think was excellent. Now, something else you had in there, Andrew, was light scans equal force, and you had it two ways in your environment. Which one's the correct way?
I believe it's the light underscore scans.
Yeah, I put them both here just because they were both in your environment. And then tell us some more about the opt OFC equal 1.
Well, without this parameter set, when you open a cursor, fetch a row from it, and close a cursor, that's 3 network traffics. You know, 3 network communications. One to open, and then another to fetch a row, or more than one row, and then another to close. With this parameter set, it's just optimizing that. Where I believe when you open a cursor, it automatically fetches the first row. So there you've taken new network communications and condensed it down to 1. And then I believe when it retrieves the last row of a cursor, it automatically closes it. That may not be exactly what happens, but that's kind of the gist. It's just optimizing the communication between the client and the server.
And I actually think, Andrew, this was a key one. I had not even thought of trying this. This is the one thing, every time I do this, I learn something from you guys who participate. And I knew about this. I'd never thought about trying it in the context of this benchmark. And I tried it, and it does make a difference. Basically, you can see it in the reduction in network traffic. And if you have the transaction manager on a different machine, it makes a bigger difference. And then the last thing that you did, Andrew, that I thought was brilliant was creating the 3 very large logical log files. One of the things that happens in this benchmark, because you're going through transactions so fast, it goes through logical logs. And there's a little bit of overhead every time you have to change logical log. And having 3, I don't think you even use more than 1. I don't remember looking at that right after you ran, but I think in the 10 minutes you stayed on logical log. And that was great. Now, something you didn't do, Andrew, was update stats high, and other people did that.
Mm-hmm.
Any thoughts on that?
Well, I just didn't feel like I had enough time to spend the time running update statistics, and then after running the benchmark, being able to run the benchmark during my 40 minutes and taking a look and seeing what queries were being run, it didn't seem like there were any SQLs that were taking, you know, a really long time where it was choosing the wrong query path or anything like that. So I just decided to spend my time trying to tune other things, and then at the end just letting the benchmark run for a few minutes to prime the cache instead of trying anything with update stats.
Yeah, I think another key thing is by setting the opt-conf indicator to 0.
Mm-hmm.
Stats are important, but not as important because it's always going to choose the nested loop join versus deciding based on stats whether to do a scan or not. And I think if you didn't set opt-conf indicator to 0, stats would have probably been important. And you just pointed out one of the hard things about this contest is you don't have enough time to build indexes or do unloads or do move tables around, and update statistics high is one of the things you really don't have time to do. That's part of the challenge.
Yeah, it's a big commitment that may not work out, you know, may not get you anything. If you're going to spend the, you know, the 20 to 30 minutes, you know, writing out the commands and running them, you know, you may not get anything for it, so.
Well, cool. Well, congratulations. That was, again, you did awesome. And what I'm going to do now is open up the floor to questions. And the best way to ask a question is if you go up to that green bar at the top of the screen where it says viewing Lester Knutsen's desktop, you should see a chat window there. And if you type a question in the chat window, I will see it, and I can ask Andrew about it. And we have Art Kagel here. I'm going to unmute Art so that he can participate in some of the questions. Art, are you there?
I'm here.
Okay, we got Art on the line too. And first off, Art, you started to make a comment in the chat about something. Why don't you go ahead and tell everybody about your comment about the
Yeah, Andrew said he wasn't sure about the mechanics of open fetch close optimization. So what happens is the open becomes a no-op statement and nothing happens, and the open is delayed until the first fetch. And then, as Andrew said, the close happens automatically when you drain the cursor and pull the last record back. And so the close becomes no-op also. And that saves, those two things save a lot of communication for very small transactions, which is what this benchmark is all about.
Now, another question in the chat is, how about direct I/O? And that's actually something I didn't talk about in the benchmark rules. And I think it's probably spend a few minutes on that. On the Mac, direct I/O does work up to a point. And where it doesn't work is when you have this many transactions going on. The kernel actually runs out of resources. There's a hard-coded limit in the Mac OS. And with 1,000 sessions connecting, it actually runs out of resources, and you'll see error messages on the Mac. So I didn't tell anybody this, but I had the environment variable set to turn KAIO off, and I was hoping people would avoid direct I/O. And if anybody had tried to do it, it probably would have been ignored because I had that environment variable set. If the environment variable was not set, they would have gotten error messages. But direct I/O is usually very good. On the Linux servers we used last year, they make a big difference. Another question somebody asked is, can we get a copy of the PowerPoint and the on-config spreadsheet? And the answer is yes. It'll probably be a few days, but I'll have it up on the website where you registered for this. We'll also should have a recording of this webcast available. And then another question is, what were the transactions doing? And basically, this is a TCP/C benchmark. It's an open source version of it, written in Java. And so it's all doing a mix of selects. I think it's about 80% selects, but then about 20% updates and inserts and deletes. And it's all random. It has a random generator in this, and that's basically how it runs, the benchmark. There are 10 tables. It's the classic, if you're familiar with TCP/C benchmarks, it's their classic 10-table design where you have warehouse stocks and items and things like that. You know, it's not a very real life benchmark because everybody who runs a production system like this has a much more complicated database than just 10 tables. But it is good. I use it a lot to compare hardware. I use it to compare different databases. And being an open source Java program, you can do that. A couple of other questions. Wow, I've got a stream of them here. One question was, could you change the database to non-logging? And the answer is no. That was one of the rules that we applied to everybody. You could not change the logging mode of the database. And the real reason for doing that is we didn't want to change the Java code, and the Java code had begin transaction calls in it. And so if you change the base to non-logging, the Java transaction manager would have quit and generated errors, and you would have got 0 transactions. Somebody else asked a question, can you obtain the code for this? And the answer is maybe. I'm still working on getting it out. I will have links to where you could go download benchmark SQL yourself and recompile it. The pre-compiled version for Informix was done by the folks who bring you Server Studio, AGS. I need to check with them to see if we can do the pre-compiled version and get that out to everybody. But check back. Another question. And I'm going to let Art answer this. The open fetch close, when is it better to leave that as a default instead of turning that on?
To leave it defaulted?
Yeah, to not turn that parameter on.
The only advantage to leaving it turned off is if you have code that's using describe, then since the open is deferred, it can sometimes interfere with the way that describe and prepare work. There's another parameter that also can give you additional optimizations by delaying the prepare until open time. That combination of open fetch close with that other parameter, if you have real dynamic SQL, can cause you code problems because those descriptions won't be available before the cursor opens. So you'd have to look at those data structures after the first fetch rather than after the prepare or before the open. That's the real difference. If you don't have dynamic code, then there's no good reason not to turn it on. Both optimizations for that matter.
Cool, thank you. I was going to say, Andrew, have you found any downside to turning it on ever?
No, not for us, because we don't, we don't do any of the things that Art was just talking about. We're not using true dynamic SQL where we need to describe any of the rows coming back.
Another point here. a while back, Eric had posted something on the news groups and on a couple of places about a benchmark he had done using ESQLC code. And he just made a note here that it will be available soon for folks who want to try it out. I'm really looking forward to working with Eric's code because there is, one of the problems with this benchmark is there is overhead with the Java Transaction Manager. And doing a benchmark in ESQLC is probably going to be the fastest and most efficient transaction manager. The downside is it's not going to be very portable to other databases. But Eric, we look forward to seeing your code when it's out, and let us know. And we'll look forward to trying it out. Now, hang on, I'm just going to mute everybody for a minute. We've got some background noise, and I'm unmuting Andrew and Art.
Yeah, I'm going to mute myself again because I think most of the background noise is people walking by.
Okay.
By me.
No problem. Eric just sent me another note saying early July we may have the code available. That would be cool. Well, I don't see any more questions, but I'm sure if you have some, please drop us an email. And you know where Andrew's blog is, drop him an email. I just want to sort of, as a host, just talk a little bit about advanced data tools and what we do. We focus on Informix training, performance tuning, and upgrades. And one of the things that we do, Art and I both teach this class. We have one next week, and we still have place if anybody's interested. But you spend 4 days running this benchmark. You know, if you told your boss I was going to play video games for 4 days, he might not let you come. But that's basically what this class is like. It's 4 days trying this benchmark over and over again until you get it as fast as possible. And it's always good to see students from the class who do well in the contest when we do it. But in addition to that, you're going to get 4 days with Art and me telling you about all the cool stuff you can do with your database. So it's going to be a lot of fun. And with that, I would like to thank Andrew for sharing your results with us. One of the great things about the Informix community, I think, is we are very open, and it's a great community to be part of in terms of sharing of results and how to do things. And what Andrew did today is a good example of that. And I'd like to thank everybody for participating in this webcast. And we will probably in about months we'll have another series of performance tuning webcasts, and hope you'll join us again for those. Well, thank you all.
Thank you, Lester.